So this section is about heterogeneous equilibria. So here our reaction involves solids and liquids as well as gases. So the concentration of a solid, a pure solid or a pure liquid, doesn't change. It's really related to the density of the object, right? And as long as there's some there, the concentration is the same. So because of that, when we write an equilibrium expression for a reaction involving a solid or a gas, and solid or a liquid, we don't include those species in the reaction. In the expression. Too many words. So let's write the equilibrium expression for the reaction between carbon dioxide and water. And we'll do Kc in terms of concentration. So I'm looking for concentrations of products over concentrations of reactants. So can the concentration of hydrogen ion dissolved in water change? Yeah. It's an aqueous solution. You could have more or less. And the coefficient the coefficient is 1, so the exponent is 1. And then we have HCO3 minus, the bicarbonate ion. Also a solution, concentration can change. Divided by CO2 is a gas. Can its concentration change? Yeah, it can. I got the concentration of CO2, no coefficient, and then water. Water is a liquid, and its concentration can't change, and so it does not get included in here. So liquids or solids, ignore them for the equilibrium expression. No. Let's do another one. Here they're specifying they want Kc. I'll give you a minute to think about it. Yeah, it's just going to be the concentration of CO2. Because this is a solid and that's a solid. So the equilibrium constant is equal to the concentration of CO2. Let's do another one. So I'm looking at my products. Yeah, I'm going to have the molarity of Cl2 squared. The liquid doesn't matter in terms of this expression, divided by HCl to the 4th power and O2 to the 2nd power. Okay? Yes?
Why is the O2 to the 2nd power?
Because I'm dumb. Again, I'd love to say I was just trying to trick you, but I just was being dumb. Thank you for asking, because it shouldn't be. Just got carried away with O2. And if you think about it, if you're going to try to calculate the molarity of water, right? Well, you can calculate it. It's about 55 moles per liter. But it's not going to change. It's always the same at a given temperature, and the same for solids. And so those get left out. Okay, For which of these reactions does Kp equal Kc? Yeah, it's B. We're only looking at gases and aqueous things. Here there's 2 and 3, not the same. Here I have 3 and 3, so that delta N is going to be 0. And down here I just have gas products, and so it's also not going to be the same.